Solving one-step equations. This is going to deal with solving one-step equations using multiplication, division, addition, and subtraction. To start us out with this, I've got a picture of a tile floor that I took, and I took this picture in the ruins of Pompeii, and it was just amazing to me how, first of all, this mosaic tile, I mean, these were itty-bitty, like the top of your pinky size pieces of tile, and they were everywhere, and it's amazing to me that they were able to survive all these years plus survive a volcano like that. The first thing that we have to do is talk about a little bit of vocabulary, and we're going to discuss inverse operations. This is something I'm going to talk about a lot this year, the inverse. You'll hear me ask that a lot. What's the inverse? The inverse just means the opposite. So on the left we'll have the operation, on the right we'll have the inverse. So the inverse, or the opposite of addition, is subtraction. The inverse of subtraction is addition. The inverse, or the opposite of multiplication, is division, and the inverse of division is multiplication. When you're thinking about equal signs, think of a giant scale. Both sides have to be balanced. So in order to balance them, you can only move things on and off as long as you're doing the same thing to both sides. So some mathematically legal things to do to equations. You can add the same number to each side of the equal sign. So say your scale's already balanced, you can put 5 M&Ms on one side and 5 M&Ms on the other side, and it's still going to be balanced. You can subtract the same number from each side of the equal sign, and the scales will still be balanced. So if you've got bricks on each side, if you take 2 bricks from one side, as long as you take 2 bricks from the other side, the scale will still be balanced. You can multiply both sides of the equation by the same number as well. As long as you're multiplying by the same number on each side, it will be equivalent. The same thing with division. You can divide each side of the equal sign by the same number and still get an equivalent value. So with multiplying, you could think of doubling each side. If you've got the same amount on each side and you double it, it's still going to be the same amount to each other. Same thing with division. You can divide it into fourths. If you have 1/4 as much as you had before, you're still going to have 1/4 as much on the other side, so they will still be equivalent. Okay, so a little bit of story here. A few years ago, they had a television show called Celebrity Fit Club. I never actually watched it, but I kind of got the gist of it from the television advertisements. And you had a bunch of celebrities that would stand on one side and a bunch of celebrities that were on the other side, and the scale teetered back and forth, and it finally stopped and showed which side was heavier. Well, let's say the scales are balanced. If you've got balanced scales, and let's say you've got Mary-Kate Olsen on one side and Ashley Olsen on the other side, if one Olsen sister steps off on one side, in order for the scale to be balanced, the other Olsen sister has to step off on the other side. As long as you're taking an Olsen sister away, you're still equivalent. That's not going to work with these characters here, though. If you take an ant off one side, you can't take Shrek off the other side and expect the scales still to be balanced. So you can't take off 2 on one side and take off 27 on the other side, because your scale will not be balanced. Let's look at an example. Example 1, we've got y plus 6 equals 15. I want you to picture this being on a giant scale. And y plus 6 is on one side, 15 is on the other, and the equal sign is at that center tipping point in the middle. To help us keep that in mind, I want you, every time you do one of these problems, to draw a line through your equal sign. That's going to make sure we're using the same operation in the same amount on both sides. On the left, we've got y plus 6. I want to get y by itself, so I have to isolate that variable. The inverse of adding 6 is going to be subtracting 6. So if I take away 6 on the left, in order to keep my scale balanced, I have to do the same thing on the right. 6 minus 6 is 0, so I'm just left with y on the left. 15 minus 6 is 9. So my final answer is y equals 9. Your turn to try. Remember to use your inverse operation and put it on both sides. If you got it right, give yourself a smiley face with a mohawk. If you got it wrong, put an X, go back and fix your mistake in your work, not just in your answer, and then circle the X once you do have the correct answer. Let's look at this one. Example 2, negative 2r equals 18. So this negative 2 is multiplying with my r. Even though it's not shown, that's the operation that's insinuated when there's two things right next to each other. So the inverse of multiplying, or the opposite of multiplying, dividing. So I'm going to divide each side by a negative 2. Negative 2 divided by negative 2 is 1. So that just leaves me with 1r, or simply r. 18 divided by negative 2. A positive divided by a negative is a negative, so that's going to leave me with negative 9 for my answer. Try another one. For this problem, d equals a negative 100. The last problem, sorry, forgot to tell you the answer for that one. For the last problem, your variable gives you a positive 55. That was for the Mohawk question. For this one, if you get d equals negative 100, give yourself a smiley face with some glasses, because you're turning into quite the smarty pants, and one of the signs of being a smarty pants is sometimes glasses. So you can give them some nice curly hair as well, because you're off to a great, brilliant, wonderful start. If you did not get negative 100 for this problem, put down your X. Once you do get the correct answer and find the math to get you to the correct answer, circle your X. Here are your 4 homework problems tonight.